Now, for number one, we are not dealing with inequality. We have an equation. So, we talk about fractions, and we said what? We said we all hated fractions, right? And even more, we hated the denominator. So, what can we do to not deal with fractions? What do we say on day 1 or 2, whatever? Multiply by 7, because that will effectively remove the denominator. And I'm going to write down something and see if you can spot my mistake, okay? Okay, all right. So I multiplied it in. How many mistakes did I make? 2. Which 2? I didn't distribute right, okay? So make sure you distribute properly, okay? I hope that when you see something wrong, it bothers you, it hurts your eyes. You are requesting an eye surgery because it really hurts, okay? For somebody to make this kind of mistake. So then we just combine like terms, easy stuff. So you subtract 3x on both sides. So the left-hand side becomes just 2x. What's the right-hand side? 35, you add 28 on both sides, so it becomes 35. And 35 divided by 2 is 17.5. Okay, so we have this single value. It's not an inequality, it's single value. So on the number line, somewhere along the number line, you just write down 17.5, and we are go ahead and use a closed circle. Open circle means we're not including it. So so we are including this 17.5. So, that's it. Okay, so that's the number line representation of the solution here. Again, solution means what? A value that make a statement true. Okay, so 17.5, it's the only value that we have here, which would make this statement true. Did you all learn set builder notation back in Algebra 1? No? Easy stuff, okay? Nothing to worry. So set builder notation, it's going to start with a brace, and it's going to end with a brace, but I'm going to do that at the end. So first, you would write down what the variable you are talking about. So in this case, we are talking about x as the variable. And then you write down a vertical stroke. That means such that, okay? It's not about absolute value. So we'll say x such that, and then this easy part. Whatever you found on the left-hand side, you just copy it over. So the whole interpretation of the set builder notation is that x such that x is equal to 17.5, okay? Now, we're going to do this for just some time, not all the time. And if you move on to pre-calc and calculus, we definitely don't use set builder notation. We use interval notation all the time. Set builder notation, it's what you would use if you become a math major. Okay, math major would use it, but for us, usually we just say interval notation. Now, how would you express this interval notation? Do we have an interval right here? It's only a point. So if we have to, kind of force the idea of interval to express a point, so we'll say from where to where? From 17.5 to 17.5. Okay, and to show that we are including 17.5, we are going to use brackets. So I'm going to let you write down first, and then I'm going to do some more annotation on the symbols right here. Okay, so bracket 17.5, comma 17.5. So we don't usually use interval notations to express a single value, but well, We have a single value here. So we'll learn how to express the single number solution with an interval notation. So this opening bracket means from, and bracket also has a meaning of it being inclusive. So we are saying from 17.5 and also including 17.5. This comma means to, that could be new. Okay, so from 17.5 to 17.5, and a close bracket means it ends right here, and also it's a bracket, so it is inclusive. Now we will see some examples in a short moment. That would be exclusive, okay? So if it's exclusive, we will use another symbol, but for now, we use bracket because we're including 17.5. So the idea is this: if you have a single point or single value as your solution, so it's like, oh yeah, you're going from 17.5 to, yeah, same number, 17.5, and we use brackets to express that. Okay, so nothing too complicated. You should know how to do this stuff on the left. You just have to make sure that you are absorbing this new way of writing your solutions. Okay.